Okay, so we're recording. I'm recording this outside of class. Like there's no class in here with me. I'm just getting it down to make sure everybody that misses the day has a recording for Monday, August 23rd. Some of the stuff in here isn't really a part of a lesson. It's just information about the class. I actually am eliminating some of the stuff we did in class. So you can skip through this pretty quickly. The bell work is really the main part of the lesson. So let's go to the, shoot. There we go. So this was the bell work we did. Let me get rid of this thing down here. We didn't even get to number 3. There it is if you want to try it real quick. We're going to do that. And we did do the answer, but we didn't do the lesson behind it. So all we really did was number 1 and number 2, and then I went over some of this stuff up here in the box where the cursor is. So what is an equation? Oh, if you want to try to answer these real quick, you can pause it. I'm just going to go straight through. You can try to do number 1 and 2 while you pause it. But what is an equation? We said the very most basic definition of an equation is it's a rule. It's a rule you have to follow. A better definition, more specific definition, is it's a rule that says the left side of an equation has to equal the right side of an equation. So for example, if I kind of use the same equation that we used when I did the Mr. Gill can read minds thing, we said that this was the equation I was solving in my head to figure out what your number was. We took an unknown number, which was your starting number, and I just, in my head, made that the variable. I made that x. I knew that you were then multiplying that number by 3, and then you had to subtract 2. And then I asked you, what was your final number? What was your ending number? And maybe you said 10. So from there, I solved it by doing the opposite order and the opposite math operation. I added 2, and then I divided by 3, because that would be the opposite of what you did. And that's how you solve an equation, is you go backwards and you do the opposite. So the rule behind this equation that allows me to solve it is that I know that this left side, I'm going to get rid of some of this stuff. Oh, I got to apparently, oh, what's going on? Why is this not working? Oh, man. Shoot. All right, I'll write it again. 3x subtract 2 equals 10. So the rule for this equation is the same as the rule for every equation, really. The left side, ignore that stuff above. That was, this stuff up here is for the word problem that we're not going to do. So the rule for really every equation is the left side has to equal the right side. That's what allows me to solve. If I know the left side has to equal the right side, there's only one number that I could plug in for x, because this is 3 times x. Remember, if you don't see multiplication in between a number and a variable, that means they're being multiplied. So it's 3 times x subtract 2 equals 10. Well, I could solve it out by adding 2 and then dividing by 3, but I could also just plug in real quick numbers. 3 times 3 is 9. 9 subtract 2 is 7, so that didn't work. 3 times 4 is 12. 12 subtract 2 is 10, so 4 does work. Again, the only reason I can solve that is because I know that the rule is the left side, which is all of this, has to equal the right side, which is this, and now I can solve it. 4 being the answer. So we went over that. Oh, we also said that an equation is like a scale, because anything I do to one side of the scale, I have to do the exact same thing to the other side to keep it in balance. So if you'll remember, I said I like to fish a lot, so I drew out a scale. This is not my most fantastic art, even though I'm a fantastic artist. I said if I put a jig head on one side, that side's going to go down now. So in order to keep it in balance, I have to add the same amount of weight on this other side to keep it in balance. And then if I keep adding weight to one side, I got to add weight to the other side. If I subtract weight from one side, I got to subtract weight from the other side. It's kind of the same principle as Mr. Gill's most important rule. Whatever you do to one side of an equation, the left or the right, you got to then do it to the other side, the exact same thing. So that's how it's like a scale. An equation is like a scale. Like terms. So number 2, what are 2 things that we need in order to combine like terms? I'm sorry, what are the 2 things we need in order to combine terms? If we can combine them, then they are called like terms. So let's take this or it's actually not going to be an equation. It's going to be an expression because I'm not going to put an equal sign in it. Actually, I'm going to put one more. There. That's what we have. So this is an expression. There's no equal sign. You can't solve because there's too many variables and there's no equal sign anyway to say the left side equals the right side. So if there's no left and right side, you can't solve it. Even if we did have a left and right side, we might not be able to solve it because we have 2 variables in this. So a like term has 2 rules or 2 criteria or 2 things that have to be true. One, they have to have the same variable. And that's the same thing as saying same letter. The variable is the letter. We're not really going to deal with symbols like elephants or zebras or squares or circles. It's always going to be letters moving forward. So you could also say same letter. And that's actually what I said in class was same letter. And same exponent. This is the part that trips people up sometimes. The exponent part. So I have to have both of those 2 things to be considered like terms. So, I can expand it. So again, like terms, that's what we're talking about right now. Like terms. These are the kinds of terms that you can combine. If they're not like terms, you can't combine them. So I'm going to get rid of some of this writing. I don't think this is going to work. You can always, if you didn't get that yet, you can always rewind it and write it from that. I'm going to keep moving pretty quickly, though, since it's a recording and you can rewind it. So if I need to combine, or if I want to try to combine all the terms that I can in this expression, I need to find like terms. So again, quickly, I need same variable, same letter. Well, that's pretty easy. Certainly with this one. Oops, I got to change to a pen. I have changed colors too. There's an X, there's an X. Pretty simple to find the same letter. Now, though, I need to check and say to myself, just the variable, I don't care about the 3 and the 5 yet, does just that variable X have the same exponent? Well, I don't see an exponent, so that's a pretty good hint that it does. But technically, there's a 1 on both of those. Technically, there's a 1 on everything except for this y squared at the end. If you don't see an exponent, there's a 1 there. So yes, those have the same letter, X and X, and the same exponent. They have a 1, and a 1 is the exponent. So that is same letter, same variable. That means this term and this term right here are like terms. I can combine those. Now, if you think back to the little demonstration I did about variables and equations and the bags of candy, in this situation, we could say that X is a bag of Tootsie Rolls. It has a certain number of Tootsie Rolls in it. That's the candy we could associate with that if we wanted. We don't know how many Tootsie Rolls are in there, but we do know it's Tootsie Rolls, and we know however many Tootsie Rolls are in this one bag of X, it's the same number in every bag of X. It has to be. Every bag has to have the same number or same number of pieces of candy in it. So this X is Tootsie Rolls. Every bag of Tootsie Rolls has the same number of pieces. So the way you could read this equation then, oh boy, I'm going to have to go backwards for a little while, is you could say, okay, well, I have 3 bags of Tootsie Rolls right here. That's 3 bags of Tootsie Rolls. Over here, I have 5 bags of Tootsie Rolls. Now, this is a little tricky. I should have used addition maybe. I guess I could still change it to addition, make that addition. That's easier to understand. So let's make that addition just for this, because that's what I did in class. So that's adding. So if I have 3 bags of Tootsie Rolls, I'm going to draw a little bag. Oh boy, that's horrible. Okay, I'm not going to draw the bags. So if I have, just picture in your head, 3 bags of Tootsie Rolls. We don't know how many in each bag, but we know there's 3 bags and they all have the same amount. Then I'm adding over here 5 more bags of Tootsie Rolls. Well, that's actually how you combine like terms. You just say, okay, well, if this is 3 bags of them and I'm adding 5 more bags, well, that's just 8 bags of Tootsie Rolls. So the coefficient, so this number in front of a variable is the coefficient. We'll get to what these numbers are called in a minute. So that just means I combine the coefficients. In this case, I changed it to addition, so I'm adding them. If this would have been subtraction, we'd have to say 3 subtract 5. But we'll get to that on another day. So now I need to say, okay, do I have any more like terms? Well, here's another letter. I got a y, but there's no other y anywhere in here. So I don't have any more like terms with this y squared. All right, well, let me move to this 2. Well, I don't have any letter at all. There's no variable at all there. So I need to look and see, do I have any other terms with no variable? Well, yeah, I do. This 7 right here, this technically negative 7, there's no variable right there. So those are also like terms. If you ever just have numbers, no variable, that's called a constant. If you remember that word, it should be in your notes. So that is a constant, that's a T. So the 7 and the 2 are constants. I'll do this in black since I did them in black. The 3 and the 5 are called I'm going to have to come down here because I'm writing with my finger. Those are called coefficients. So remember, the number in front of a variable is the coefficient. The number just all by itself with no variable is a constant. So whenever you just have numbers that are constants, you can always combine those. So we can come up here and we can say, okay, well, if I have a 2, go back to red. If I have a 2, and then I'm subtracting 7 from 2, that's going to be negative 5, or subtract 5. If you're not sure how that works, you can think about money. Think about if you had $2 and a bully comes up to you and he says, give me $7. All you can do is give him 2. So you give him your $2, you still owe him or her $5. Well, if you owe money, that's negative 5. So again, dollars works really well when you're thinking about positive and negative numbers. Kind of the same thing. Well, I'm not going to worry about that. We'll just stop there. Next, I've combined the constants, the 2 and the negative 7. I've combined the 2 terms that have x in it. I still have this y squared thing. That didn't go away. So I have to just come in here now and just say, okay, well, I couldn't do anything with the y squared. That's just going to be plus y squared. Still have to bring it down, can't forget about it, but there's no other like term to combine with that. So we just simplified an expression. So the expression up here, that's an expression because there's no equal sign, but we were able to at least simplify it, combine some like terms, and make it a little shorter expression down below. It's only got 3 terms down below instead of 5. And I think that's everything for this quick catch up. Oh, I'll talk about a couple of things in case you missed it in class. I'm mainly going to talk about makeups and the next exit ticket, although you'll hear me talk about the next exit ticket probably in class. So for makeups, if you miss a quiz or a test, you are responsible for making that up. You have 2 types of codes you'll see in your focus grades. One is this little guy. It's called an asterisk, but it looks like a super teeny tiny star in focus. That means it didn't count against you, whatever the assignment was. And this only applies to your exit tickets and your quizzes. You never make up classwork if you have a little star by it. It's not something you can make up because we just did it in class that day. But an exit ticket we do in class, you can make up, but you don't have to if you have this little star. it doesn't count against you. So it's up to you if you want to make it up. Sometimes it's worth it because sometimes they are easy, but if it's been a long time since you saw the material, you may not do well on it, and then it could hurt you if you take it. So you just kind of, you and I can talk about that and determine whether or not it's a good idea for you to make those up. This is the important one, though. You'll see in there a Z, and next to the Z, it'll say missing. These you have to make up. And I only do those for the two biggest quizzes of the quarter. So there's only two possible things you have to make up every quarter. These count as zeros in your grade. Some of you got a 0 last Friday because you weren't there and you didn't take that exit ticket. That was only really for 5th period. Any other class? Actually, I think I may have put Z's in for everybody just to show you that your grade goes way down if you have a missing assignment, a missing quiz. Anyway, if you see a Z, a missing in there, you got to make that up. It counts as a 0, so your grade drops a lot as soon as I put that in there. But that's what reminds you that you need to talk to me and make that up, is because your grade drops so low. So make sure you make those up. The one last Friday was really easy. And that's, I think, all I'm going to do for this recording. I'll go over a lot of the other stuff again in class next period.